Good afternoon. I'm Steve Lee, the moderator for this session. My day job is Dean of the College of Arts and Sciences here at CU and Professor of Anthropology, and it's a real privilege to be the moderator for this particular session. I need to do my standard moderator things, like make sure that everyone's cell phone is off. So cell phones off, all other electronic devices, pagers, do those still exist? Need to be off as well. I need to give the date and time. The date is April 12th, 2017. It's 1 p.m. and this is panel 3502. We have a very special guest with us here today who is our featured speaker. We also have another very special guest, Jim Hurrell, Dr. Jim Hurrell from the National Center for Atmospheric Research will introduce our speaker. It's a privilege to have him here. He works on climate variability, and climate change. And we're very happy he's joined us for the Walter Orr Roberts lecture. One last thing, housekeeping. We'll be utilizing the CWA app for questions. Note also that we will be able to handle index card questions if you'd rather go that route. And please raise your hand at any time to request a note card and a pencil. So, Jim, thank you.
Well, good afternoon, everyone, and welcome to the Walter Orr Roberts Distinguished Lecture Series. As Steve said, I'm Jim Hurrell, and I have the pleasure and the honor of serving as the director of the National Center for Atmospheric Research here in Boulder. And it's my great pleasure to introduce today's speaker, and I'll get to that in just a moment. I want to spend just a very brief moment or two introducing this lecture series. The Walter Orr Roberts Distinguished Lecture is organized and supported by the University Corporation for Atmospheric Research here in Boulder. This corporation, UCAR, is a nonprofit consortium of more than 100 colleges and universities across North America focused on research and training in the atmospheric and Earth system sciences. It's also UCAR that manages on behalf of the National Science Foundation, NCAR. And so for all of us at UCAR and NCAR, I welcome you, and I'm extremely pleased that you are here today. You're in for a real treat when you hear today's lecture. Just a few words briefly about Walter Orr Roberts. He will forever hold a very special place in the hearts of many of us, I'm sure, here today, and certainly in my organization of UCAR and NCAR, because he was not only a truly visionary scientific leader, but because he was just a terrific person, a terrific individual, with a very strong moral sense, endless energy, a person who is extremely generous, a person who loved to teach and interact with the public, a person that cared very deeply about humankind as well as the environment. In our scientific community, Dr. Roberts presided over the founding of NCAR and was NCAR's first director from 1960 through 1968, and simultaneously he was the first president of the University Corporation for Atmospheric Research and remained president until 1973. He was also a driving force in establishing Boulder space and rocket science communities that later spawned such things as the University of Colorado's Joint Institute for Laboratory Astrophysics and what today is Ball Aerospace. Among many, many tributes that Dr. Roberts received during his outstanding career was the United Nations Environment Programme's North American Leadership Award. In fact, Dr. Roberts was the first scientist to be so honored. So as a result, we have this lecture series, which is just one very, very small way to continue to honor him as a person, as a leader, and honor his legacy. Just even briefer, a few words about the lecture series. The first Walter Orr Roberts Distinguished Lecture was given in 1998 by one of our own scientists at NCAR, indeed a true pioneer in atmospheric and climate modeling. That is Dr. Warren Washington. And you can see the list, some of the pictures up on the screen. Catherine Hayhoe in your lower left was the lecturer in 2014. 2015, Richard Alley there in the middle. Jim Hansen in the lower right, and the like. So today, it's my great pleasure to introduce Dr. Kerry Emanuel. He is another giant in our field in terms of research, but I can just say as someone that has known Kerry for some time that much like Walter Orr Roberts, I and many others respect Kerry just for the terrific person that he is as well. Kerry is the Cecil and Ida Green Professor of Atmospheric Science at MIT, where he's been on the faculty there since 1981. Previously, he spent some years at UCLA. His research interest and focus and what he's really known worldwide for are his efforts in tropical meteorology and climate with a specialty in hurricane physics, and he's going to be talking about hurricanes today. Kerry is the author or co-author of more than 200 peer-reviewed scientific papers and 3 books. Among those books, one is called Divine Wind, The History and Science of Hurricanes, and this is an excellent book. I would encourage you to take a look for it. It's aimed at a general audience. And also What We Know About Climate Change, which is published by MIT Press. He's also co-director of MIT's Lorenz Center, which is a climate think tank devoted to basic curiosity-driven climate research. And today, he's going to be speaking on hurricanes, climate, and culture, how we cope with natural disasters. But before Kerry begins his talk, I'd like to mention that there are several members of Dr. Roberts' family in attendance. First of all is Walter's youngest son and his wife, John Roberts and Elaine Smith. So I don't know if you're willing to sort of stand up. And Walter's granddaughter, Kim McKean. And then finally, I would like to call up on stage not only Kerry, but Walter's great-granddaughters, Olivia and Lauren McKean, who are going to say just a few words.
On behalf of the Roberts family, I'd like to present this award to Dr. Emanuel for his dedicated work in science.
Well, good afternoon and welcome. I want to thank both Steve and Jim for their very generous introductions, and also thank the CWA for hosting me as well. This is my first CWA, and I came in on Sunday night and have been attending sessions these last 2.5 days, and really, really impressed by the organization and by the diversity of topics and viewpoints, and what a model for some of the rest of universities to try to mimic in the future. I am going to talk to you today about something that interests me a lot, which is hurricanes and how they influence society. But let me say that I first came to NCAR in 1976 as a young graduate intern and for the summer, and I was very privileged to meet Walter Orr Roberts then, and on a few occasions after that. And one of the many ways he's inspired scientists in my profession is to show that not only could you spend part of your career doing real scientific research and advancing science and society that way, but you could actually sort of harvest science in service to society. And there are a lot of scientific subdisciplines when this is actually almost frowned upon. And he broke that barrier in ours, and I think with very, very nice results. And I've tried to fashion my lecture today in that spirit. So what I'm going to do today is to begin talking about hurricanes, just a very brief review of what they are, so we're on the same page, and start right away to talk about their influence on humanity, hurricane disasters. How do they actually influence us? And how does society respond to hurricanes? This is really more drifting into the social science side of our profession, but it's terribly important and terribly productive for physical scientists like me to talk to social scientists, people who have to actually deal with disasters, so that we can work together to try to minimize them. And I'll talk a little bit toward the end of my, another topic that was of interest to Walter Orr Roberts was climate change. So how does climate change potentially influence the incidence of these disasters, and how should we try to deal with that? So let me begin with a very beautiful photograph from space of a particular Hurricane Floyd, doctored by the good people at NASA to give you this nice sort of three-dimensional impression of it. And you look down from space, you see this swirling mass of clouds, a few hundred miles across typically, often surrounding this clear eye, which you can see quite clearly in this image. And the heaviest rain and the strongest winds are in a kind of a donut-shaped annulus surrounding that eye, which we call the eye wall. Now, outside the eye wall, the rain is organized into these beautiful spiral bands, which you see in this photograph. That's what you see when you look down from space. This is another space photograph, but this is from the International Space Station, zooming in on the eye of another hurricane. These are really, when you look at them from space and you don't have to deal with them at the ground, they're really, like many other natural phenomena, beautiful, you know. Lions and tigers and bears are beautiful. They'll rip you apart if they get the chance, but we still appreciate their beauty, and we can do the same for hurricanes. Now, since the 1940s, we've been routinely flying both research and reconnaissance aircraft into hurricanes to make measurements, both for operational forecasting, the practical side of it, and also for making measurements in aid of research. And these are two aircraft operated by NOAA. They're P-3 Orions. I've been privileged, and quite a few of my colleagues, to be on some of these missions. You fly into the eye of a hurricane, and the first thing you realize is there's no way you can capture that experience with a camera. It just doesn't work. You have to kind of imagine yourself standing in something like a stadium, a football stadium, but instead of being a few hundred meters across, it's maybe 50 miles across. And it has these white walls that go up about 12 miles. And there's often a cascade of ice crystals, like a waterfall coming down the inside of the eye. And I really feel that everybody should see this. And so one of my retirement projects is to start a hurricane safari and to take customers into the eyes of the hurricane. Hurricanes have had an enormous influence in culture for a long time. And the early inhabitants, the pre-Columbian inhabitants of the Caribbean, of course, were very familiar with these and terrified of them, and fashioned their gods of evil after a likeness of hurricanes. And you see here an image of a god that the Mayans called Huracan, and the Taínos and Caribs had very similar words for this. It was their god of evil. And it was that word which was literally heard by Columbus on one of his voyages and brought back to the old world, and gradually took the form that we now call hurricane. Hurricane's a strictly regional name for a class of phenomena that we in our profession call tropical cyclones, and I may use those terms interchangeably. Now, what I think is quite remarkable about this image is that you have to see the spooky face and then these arms extending from what should be the ears, warped into a spiral, okay? Now, you know, this is a long time, 1,000 years ago, or a little bit less than 1,000 years ago, this age. It wasn't until the middle of the 19th century that Western scientists figured out that hurricanes are rotating storms, right? And there is an indication there that these ancient people had already figured that out. They couldn't see spiral bands from space, but there are ways they could have made deductions from the damage on the ground about the rotation. Now, you know, centuries later, I think by coincidence, modern meteorologists invented this symbol that they put on weather maps to denote the presence of a tropical cyclone, kind of a spooky resemblance there. A lot of the settlement of the Caribbean was fashioned by hurricanes. The Mayans mostly built cities inland in the Yucatan to avoid them. Only when they had exhausted the land did they sort of retreat to the coastline. This was one of their very last temples in Tulum, Mexico, and it was devoted to the gods of the winds, of which they were terrified. In the end, it was really the Spanish conquistadors that got them, but they suffered at the hands of these storms. And I could go on and on about the influence of hurricanes on history and on culture. They've had a tremendous influence in art for some reason, particularly in the 19th century. So I'm just going to show you one example, which is one of my favorites, which is a painting by Turner, which happens to be hanging in the museum in my hometown, Boston, the Museum of Fine Arts, and it shows a slave ship, in this case, struggling in a typhoon and throwing their cargo overboard, a real horror story, to be sure. You can find, hundreds, maybe thousands of paintings of this character. The 19th century artists, poets were fascinated by these storms. All right, well, let's now turn to the sort of more tangible impacts of hurricanes on society. What are the things that influence us? Well, the first one is what everybody thinks of course, is wind. There are tremendous winds in hurricanes. In a Cat 5 storm, winds can be up to 200 miles per hour. In 2015, we had the strongest hurricane ever measured on our planet, Hurricane Patricia in the Eastern Pacific. It's just about to enter the world record books as the strongest, and it had winds over 200 miles per hour. And yet, it isn't usually the wind that kills us, it's water. Okay, we had a little session on water this morning. Rain causes torrential floods, and this is a big killer in hurricanes. Hurricane Mitch in 1998, 18,000 people or so in Central America, all from freshwater flooding, not from wind. And then the other big killer in hurricanes is the storm surge. And the problem with the storm surge is, most of you have heard that phrase. I don't know how many of you sort of can envision what it really is. You might think of a big wave or not. And, there isn't a lot of context for this. So what I thought I'd do, if I can manage the technology, to show you a short film taken by an ordinary resident of the Philippines, very bravely, I think, of the storm surge that accompanied Typhoon Hainan, one of the worst on the records. So let me see if I can get this to go. So I think you get the impression that you're not going to survive that, right, if you're in it. It is hydrodynamically exactly the same thing as a tsunami. There's no difference. It's just that the thing that excited it was wind rather than shaking seafloor. And a lot of people don't really realize this. If you are ever in a situation where there's a potential for a storm surge, don't take any chances. Get out in advance. And it's a message we've been trying to tell people all over the world for a long time. Let's talk about some of the more gruesome statistics here. On average, over the since 1971, hurricanes worldwide kill about 10,000 people and do about $700 billion US dollars in damage. So they're a big ticket item, both in terms of mortality and economics. If we look at the United States, this is making the point that I was trying to make before. If you look at the source of mortality in hurricanes since 1970, it's mostly drowning. It's the top bar is fresh water, the second one down is salt water, and then there's wind, tornadoes, which sometimes accompany hurricanes, and other things, other hazards that may occur. But here's something really interesting, and this gets to a little corner of human culture. For various interesting reasons, these first two items, which kill the most people, are not privately insured almost anywhere in the world, and that includes the United States. Water damage, anything having to do with water, is insured by the federal government. Okay, and private insurance does the wind damage, all right? Now, the private insurance industry has motivated a lot of what we call risk modeling today, which sets things like insurance premiums in coastal places. The problem with that is that all the effort now has gone into the place where the money is, which is in those lower categories, and not enough attention, in my opinion, has been paid to modeling and predicting the flood risks with hurricanes. We just haven't done as a community a good job with that. If we look at the economics worldwide, this is just from an insurance company, in Germany. This happens to be for the year 2006, but I think it's pretty representative. Almost 80% of the damage that's done, that's insured damage that's done, is done by wind, and most of that by tropical cyclones, earthquakes, and so forth. Floods don't count for much. Now, that doesn't mean that this is the same chart for mortality or for total damage. It's not at all the same chart. But it's to illustrate to you that this is what it's wind that insurers are worried about, and we've neglected water. Now, here's the big problem that we have. This is an indication compiled by Roger Pilkey Jr., who's here in Boulder, by decade during the 20th century of hurricane damage in 10 to the 10th dollars. That's in tens of billions of dollars by decade. And you see this enormous upward trend, all right? Now, you might be tempted to think the climate's changing, and of course it is. That isn't the big reason for this. The big reason is this. It's coastal population. Now, this is not literally a chart of coastal population. It's a population of the state of Florida, a lot of which is coastal. A lot of the population is coastal, going back to 1790 and forward and projected forward to 2030 in that orange bit. And you can just see there's a huge increase in coastal population, and it continues. I'll have some more to say about that. You might see that there's been a kind of a transition or in the slope of that curve in the early 1950s. Some of you may have already guessed why that's true. It corresponds to the invention of the air conditioner, which made Florida habitable by mere mortals. Nevertheless, that coastal population trend has continued upward. Now, Roger Pilkey has gone back and renormalized the hurricane damage. This is a hard thing to do. What if those hurricanes, 50, 70 years ago had hit today's infrastructure? How much damage would they have caused? That huge bar in the 1920s is really the 1926 Miami hurricane. It's one hurricane that pretty much destroyed the fledgling city of Miami. And yeah, there were a lot in the 2000s, but it's a little bit hard to see a big trend in that. The big signal doesn't mean climate change isn't important, but the big signal is in population. So how do we cope as a society with natural disasters? And I'm just going to use hurricane as an example. You could say similar things about other natural hazards. I'm going to just look at a handful of kind of case studies with you. First, abroad, talking about the Bola Cyclone of 1970. Some of you may not have heard of that. It's probably one of the worst natural disasters ever to occur on our planet. It killed 500,000 people in the year 1970, almost entirely from a storm surge. And it just was an absolutely terrible event, and it hit a country that no longer exists. It's called East Pakistan. And it was partly a result of that hurricane and the failure of the central government in the western part of Pakistan to respond that led to the independence of Bangladesh later that year. I think it was the next year that happened. And so how has the world and how has that country responded to this calamity? This was not by any means the first tropical cyclone calamity in that part of the world. Well, I would argue that they responded in an intelligent way. Now, we have to think this is one of the most impoverished parts of the globe. If you're worried about insuring property, forget about it. There's not much there to insure. It's saving lives. All right, so this is an interesting example where the world went to work not to save money, but to save lives. And what did they do? Well, the World Bank and lots of non-governmental organizations, NGOs, went around and built thousands of these so-called storm evacuation or cyclone evacuation shelters. They're very simple. They're made of concrete. And there's usually one within walking distance of the coastal, of almost anybody who lives near the coast. That's important because people don't have cars there, typically. So you don't drive away from the disaster, you walk away from the coming disaster. And it's likely that these shelters have saved many thousands and maybe tens of thousands of lives, and they're still under construction. That's kind of a nice response. People have some place to go so they don't get wiped out by that surge that I just showed you in the film. What about here in the United States? So what I'm going to do is to concentrate on 2 case studies of how we, in fact, responded to a hurricane disaster, and let you be the judge of whether we responded well or not. But it illustrates some interesting virtues and flaws in how we do that. My 2 case studies will be hurricanes Katrina in 2005 and Sandy in 2012. Well, let's start with Katrina. Katrina was a very intense storm, a Category 5 storm at its peak. It followed this path. It began in the Bahamas. It moved over southern Florida while intensifying. The colors along that track show you the intensity of the storm. The scale is in the quaint units of nautical miles per hour. If you're a sailor, you know what that is. It's a little bit more than a statute mile per hour. The numbers are dates in August of 2005. So it intensified very rapidly, made a beeline for New Orleans, and many of you remember what happened. Here's something you may not know or may not remember, and that Katrina was an exceptionally well forecast storm. What you see on the lower left there is the probability of any point experiencing tropical storm force winds or larger. And this was made when the storm had just emerged from the west coast of Florida. And you can see that that probability is maximized along the Gulf Coast, not far to the east of New Orleans. And on the lower right there, you see individual forecasts by individual models made a little while later. It was clear pretty early in the game to weather forecasters that New Orleans and Louisiana in general and parts of that coastline were at really strong risk. So what happened? Well, let's look at just sort of an overview first. As I've just mentioned, really good forecasts, more than 3 days before landfall. It remains the costliest natural disaster in the history of our country. Among the 5 deadliest in our whole history, more than 1,800 deaths. A lot of people thought that could never happen again, and it did. Highest death toll since the terrible Okeechobee hurricane of 1928. More than 50 breaches of New Orleans' surge protection system, 80% of the city flooded, and the total economic impact may have exceeded $150 billion. So what happened? Well, beginning on 27th August, when the hurricane was well underway, the then director of the National Hurricane Center, a very competent, good person, Max Mayfield, after watching in frustration as all their warnings were just ignored by New Orleans in particular, he personally called Louisiana Governor Blanco and Mississippi Governor Barber, and just basically saying, you know, this is going to be a big deal for you. He'd been trying to reach the mayor of New Orleans, and basically the mayor refused to take his call. So he tricked him, and he broke NOAA rules to do this. He routed the call through the White House. So the mayor thought he was getting a phone call from the president, and it was Max. And Max, well, you could see what it says, scared the crap out of the mayor, in his own words. But how did the mayor respond to that? By ordering a voluntary evacuation. Well, that's not really much of anything. Why? Well, he wanted to give his attorneys time to look into his personal legal liability to lawsuits from local businesses. And this is a theme that we see a lot in U.S. disasters, is commerce often trying to postpone evacuations because they think it will hurt business. People leave and then nothing happens. Just some meteorological facts. It was obviously shaping up to a big storm, or the first storm to capsize one of the giant buoys that NOAA maintains in the Gulf. And it was upgraded on the 28th at 12 Universal Time to a Category 5 storm. Now, at 9:30 on the 28th, Central Time, the mayor finally issues, somewhat late, a mandatory evacuation order. And a little while later, the National Weather Service issued a statement. Now, if you have ever read those, they're usually extremely sober. This one isn't, okay? You can read it for yourself. The area will be uninhabitable for weeks, perhaps longer. At least half of the well-constructed homes will have roof and wall failure, and the majority of industrial buildings will become non-functional. Airborne debris will be widespread and may include heavy items such as household appliances and light vehicles. Persons, pets, livestock exposed to the winds will face certain death. Certain death. I don't think I've ever seen that in a Weather Service statement. Power outages for weeks. In other words, they sort of knew what was going to happen. And they pulled out the stops to try to get people to respond to that. Now, Katrina made landfall around 11 UTC on the 29th in the early morning hours near Burris, Louisiana, and it had downgraded to a Category 3, but it was an enormously powerful and broad storm at the time. Shortly thereafter, the mayor abandoned his post at the Emergency Operations Center in favor of the more comfortable Hyatt Hotel, which promptly lost power. So we cut off the head of the operation, or he cut himself off, and then there was sort of organizational chaos. Not so long after that, 2 major flood control levees are breached, and the Weather Service reported total structural failure in parts of New Orleans. There was a lot of fear that there'd been already a lot of deaths. In that same morning, a great many New Orleans police officers simply abandoned duty so that they could evacuate their families, and more than 200 were eventually put on trial. By the evening, 80% of New Orleans is underwater. And the aftermath is pretty much what the Weather Service said. No power, no drinking water, not much food, widespread looting, and so forth. They tried to limit the flooding, but weren't successful. And they were trying like crazy to evacuate people. This is an important cultural lesson from disasters. You have all these plans, and New Orleans did have plans, but at the end, it's improvised actions that save the day. And the U.S. Coast Guard and the Louisiana Wildlife and Fisheries Department, the latter of which had no mandate to do any of this stuff, went in with their boats and saved a lot of people. But the FEMA director, Michael Brown, basically went missing for a few days. And the politicians started the usual finger pointing. We were offered aid by Cuba and Venezuela and Mexico. Think of what would happen if we had a wall. We couldn't get all this aid. And on September 1st, on national television, New Orleans Mayor Ray Nagin issues a desperate plea for help from the federal government. Now, there's sort of a postlude to that. If you ask, where's Mayor Nagin today? He's in a federal penitentiary on being convicted of charges of fraud, bribery, and money laundering, but both before and after Katrina. So what do we learn from that? Years of planning, and there were years of planning, and excellent forecasts. I can't imagine better forecasts. They're not perfect, but about as good as you're going to get. They can't succeed where leadership fails. Leadership is still really important. And leadership failed owing, in this case, to corruption, cowardice, and incompetence. This is part of human history. Breakdown of technical and human communications is a major element in many disasters. Business interests can trump safety considerations in the lead up to disasters. Short-term recovery often depends on ad hoc and creative acts of bravery and spontaneous organization. The local culture is really a critical element both in preparing for and reacting to natural disasters. And I'm going to, I think, show you that when I contrast what you've just seen with Sandy. Now, let's take New Orleans one step further and ask an important question, and that is New Orleans sustainable? We've had this terrible disaster. We saw what happened. We could have prevented loss of human life. I don't think we could have prevented the destruction. Is it sustainable in the future? And that's where my field comes in. We have spent a lot of time trying to quantify the risk of hurricanes, and there are various ways of doing it. The way we do it at MIT is we take a large-scale climate data set, and within the time-evolving climate, we simulate thousands and sometimes tens of thousands of hurricanes based on physical modeling. And we have confidence in that only because we can compare the results to the history of hurricanes and see how well we do. So here is just a map showing, as an example, a mere 1,000 tracks. We actually use a lot more than these that are are supposed to represent the current climate downscale from a climate data set called the ERA 40 for those meteorologists in the room. The colors are an indication of the intensity of the storm, and you can see their tracks. There are no hurricanes along the equator, by the way, which is a very helpful fact to know if you're planning to sail around the world and you don't like those storms. You just stick to the equator. We can filter them so that we can only look at tracks affecting a particular place. So this is a set, you're seeing here a set of 100 storms of a larger set of 3,400 that affected New Orleans that we used to do a study of New Orleans. And here's kind of a result of that study. Now what you see on this graph is the maximum wind speed that would be experienced in the city of New Orleans. And on the bottom axis, you see something called the return period. The return period is just a way of expressing the frequency. So a return period of 100 years means that the annual probability of having a wind of that magnitude or greater in New Orleans is 1 in 100. It's 1%. So when you look at that graph, Katrina, as indicated by the arrow, is an event that we would expect in the present climate about every 25 years. I forgot to say the green dots are based on the very limited historical record. The blue dots are based on the method that I just showed you. It's one of many ways we try to validate or evaluate that method. If you wait 100 years, you're going to see a much stronger event than Katrina on average, okay? So Katrina is by no means the worst case scenario. Insurers, people who are worried about building codes tend to want to build things to last a century or so, and Katrina was not a 1 in 100-year storm. It was more like a 1 in 25-year storm. Now, we can take the same method and instead of applying it to the current climate, apply it to future climates as simulated by climate models, one of which, in this case, is a climate model developed right here at NCAR. And so what you see on this graph is a measure of the total amount of power dissipated by hurricanes, in some crude sense, a measure of their destructiveness, simulated for the late 20th century in blue, and for the rest of the century under a scenario in which we just keep putting greenhouse gases in the atmosphere in red. The shading shows you the enormous scatter between the models. That is, we apply this method in this case to, I think it's 6 models of the most recent batch that were run for the IPCC. And some of the models don't show much change at all, and some of them show a rather spectacular change. And this is what we're confronted with in the climate thing, whenever especially when we go down to local or regional scales, is a lot of uncertainty. But what I want to tell you is that uncertainty is not the same thing as ignorance. It just isn't, all right? If I were to tell you, if I were a trained weather forecaster, and I said to you there's a 70% chance it will rain tomorrow, you probably interpret that correctly, that there's a 70% chance of rain tomorrow. You don't say, oh, well, there's uncertainty, so I'm not going to take my umbrella, right? But I even heard at this conference on one of the panels someone say exactly that. These models are uncertain, so why should we worry about this? All right? That's not the right interpretation. Let's get on to the second case study, and we'll also look at the future in this connection, which is Hurricane Sandy of 2012. There's a nice satellite picture of Sandy off the east seaboard of the United States. Sandy developed in the far southern Caribbean, moved northward over Cuba, and took a very circuitous path, making landfall on the 30th of October. And I think this is recent enough that most of you in the audience remember what a terrible calamity that was. Now, like Katrina, and in sort of an unusual way, the forecasts of this storm were also, by the standard of modern weather forecasts, excellent. So what you see on the upper left there, in fact, the 4 panels show ensembles of track forecasts by global models run by the European Center. It's a European consortium in the upper left, the United Kingdom Meteorological Office, the lower right, our own NCEP in the lower left, and the Canadian Meteorological Center in the lower right. And the black curve on those shows what actually happened. So 5.5 days before Sandy influenced New York City, we knew there was a reasonable probability of a calamity in New York City. That's remarkable. That is absolutely remarkable. It's an astonishing accomplishment. This is one of the ensemble members from the European Center. It's a forecast from 4 days before the event. And that's the surface pressure. You see this big storm over southern New Jersey, almost spot on, that particular ensemble member, almost spot on. This is, the NWP development, a lot of which happens here at NCAR. It's one of the great accomplishments of science in the last 50 or 60 years, and it's kind of unsung. But meteorologists knew that there was a pretty high probability of a calamity. So what actually happened? Let's look at this. Not just in the US, there were a total of about 230 fatalities. It strongly affected Haiti and Cuba as well, as a large swath of the US eastern seaboard, about $75 billion at the time in damage. It's the second costliest hurricane in our history. While it was a Category 2 hurricane off our northeastern coast, it became the largest, physically largest hurricane in our history with a diameter of 1,800 kilometers. A spectacularly big storm. And that contributed to the very big storm surge in New York. The governor of New York, Cuomo, declared a statewide state of emergency and asked for a pre-disaster declaration on October 26, well before the event. The surge at the base of Manhattan, the Battery, was 13.8 feet. It was the largest in its history. It's the worst disaster in the whole history of the New York subway system. The New York Stock Exchange closed for 2 consecutive days for the first time since the blizzard of '88. Over 10 billion gallons of raw and partially treated sewage released into New York and New Jersey. I don't know how that compares to a normal day, but up there. And this is unusual, 1 to 3 feet of snow in West Virginia. So let's talk about what happened there. On the 28th of October, 2 days ahead of the event, the mayor of New York, Michael Bloomberg, held a press conference and explained why he was not ordering an evacuation. And it was based on the nature of the storm. It's not expected to be a tropical storm or hurricane. Now, that's really interesting. So this is a semantic problem. The Hurricane Center, rightly, in a scientific sense, that this is not going to be a hurricane, not a tropical hurricane when it's New York, all right? And the mayor interpreted that to mean it's not going to be bad, which is not what the National Hurricane Center meant. So the then director of the National Hurricane Center, Richard Knabb, got on the phone and went into high gear, a lot of sleepless nights for him, trying to explain that this is the wrong decision, this is a vicious, dangerous storm. And so the mayor did order an evacuation later, and in a particular part of New York City, and announced that the entire public transportation would shut down at 7 p.m. that evening. It reached a second peak intensity of 85 knots, a little shy of 100 miles an hour on the 29th of October, while it was southeast of Atlantic City. And the NHC continued to say this is going to be a really bad storm surge. And of course, people don't really know what that means. On the 29th, late on the 29th, the Hurricane Center declared that Sandy was no longer a tropical cyclone, but had taken on the characteristics of a non-tropical storm, but continued to issue warnings, including its very first ever snowfall advisory, not usually the purview of the National Hurricane Center. And it finally made landfall in southern New Jersey with a pretty high intensity and a very low pressure. And a record surge arrived at Manhattan shortly thereafter, breaching the seawall and flooding, as you know, the New York subway system, large parts of lower Manhattan and Brooklyn. What do we learn from this? The forecasts were really good, excellent communications between the forecasters, emergency managers, and political leaders. Bloomberg made a little bit of a mistake, but corrected himself there. Even so, we lost in the US more than 150 people. Preparations for this storm were much better than they were for Katrina, for whatever reason. Management of and resilience to natural disasters, again, depends on local culture. New York, for whatever reason, was much better prepared to deal with a hurricane disaster than New Orleans, even though New York, hurricanes are much rarer in New York City than they are in New Orleans. much confusion and a delayed evacuation resulted from misunderstandings arising from multiple culturally loaded terms, such as hurricane. Some insurance policies, by the way, will only pay out their claims if the storm was named, if it has a name. That's what's written into the insurance contract. Imagine that. So you could have a stronger storm and nobody bothered to name it. Sorry, bud, you're up the creek. No pay for you. So there's a strong impetus for revisiting the use of this terminology, the categorization of storms, etc. What about the future of New York? Well, this is a little bit more complicated. What I'm showing you, which is also work that we've done at MIT, for 4 different climate models, those 4 panels, are estimates for the current climate in black and for a climate at the end of this century in red and blue of the return periods of surge heights at the Battery. And curiously enough, we published this paper before Sandy happened. This was not a post-Sandy paper. And so, for example, if you look at the upper left panel, you might see in the current climate that a storm surge of 2 meters, might occur, look at this closely, every 100 years, maybe 200 years or so. Well, let's look at the upper right panel for a minute. And Sandy's surge height was about 2.8 meters, okay, above mean water. And that is estimated by that model to have a return period given by that arrow of about 150 or 250 years. In other words, in fact, all the models suggest that in the current climate, Sandy surge was a very rare event, a once in several hundred year event. But if we look at the projections by the same model for the climate at the end of the century, that would suggest that Sandy surge might be experienced every 50 years, partially as a result of increased storminess, mostly as a result of just the fact that sea level itself is higher. So this is the kind of thing that the city of New York actually uses in deciding, for example, if it's going to build a storm barrier, how tall should it be? So this is useful information, and we do many models, as many as we can, because there's always this uncertainty, but we have to try to quantify it. Now, the elephants in the room in all of this are 2, I would argue, population and climate change. Global population exposed to tropical cyclone hazards has tripled since 1970. That is, people all over the world are rushing to hurricane-prone areas. I don't think because they like hurricanes, but there are reasons to migrate to the coast. Sea level is going up at the same time, demonstrably, and it's projected to do so at an accelerating pace. The incidence, as I've just showed you in 2 cases anyway, but generally speaking, the incidence of intense tropical cyclones is expected to increase. So we would conclude that in spite of the fact that we're trying our best in improving the forecasts, unfortunately, the incidence of tropical cyclone disasters will almost certainly rise very substantially. And this is not rocket scientists. People are moving to the coast. Sea level's rising, and maybe storms are getting worse. Even if storms weren't getting worse, we would still have an enormous problem. And in fact, you begin to see this. This is global tropical cyclone damage from 1950 to 2015. And yeah, it's a noisy time, but you can clearly see there's an upward trend. And maybe some of that's climate, but probably most of it is this demographic trend. Now, you might think that developed countries are smarter about this, but that isn't the case. And if we now focus on the US, I will argue to you very strongly whether or not climate changes, we're going to have many more Katrinas and Sandys in our future. Why? This gets into the sociology of natural disasters. This is something all of you can do something about by educating yourself and speaking up about it. Federal and state governments, not Colorado, because Colorado is not a hurricane state, so you're high and dry here. Consider yourselves fortunate from that standpoint. But in hurricane-prone states, federal and state governments massively subsidize flood risk, not just hurricane flood risk, but other floods. How do they do that? Well, one is the National Flood Insurance Program, which was created in 1968, because then private insurance firms were shying away from this because they didn't know how to quantify the risk. So they didn't know what to charge for it. Most states heavily regulate property insurance, And many, including my state, restrict premiums under pressure from wealthy coastal property owners. There's lots and lots of literature on this, articles in newspaper and things. People live on the coast. You raise their insurance rates to reflect the risk, and they scream. And their state representative goes to the insurance commissioner and says, we need to have these rates lowered. And they are. And it's a really gruesome situation. Now, the flood insurance program also has the problem that its rates do not begin to reflect the risk. Its premiums don't reflect risk. So there's no signal. You know, in a free market economy, it's through insurance pricing that the signal of risk gets to the customers, and we're stopping that. All right? Now, Congress reformed that in 2012 with something called the Bigger Waters Act to actually allow the premiums to reflect risk. What a radical idea. And that resulted in premiums in a few places going up by a factor of 10. And you can imagine the reaction to that, right? If you had your premium go up a factor of 10, you'd be pretty angry. And so, under pressure from these folks, Congress repealed it, pretty much, in 2014. They just rolled it back. So they made a stab at reforming it. They put their toe in the water, and it got chopped off, and they pulled back. Now, I'm going to get a little bit political here. A pox on both houses. This is a problem both of the right and the left, but for various reasons. The left emphasizes in insurance policy and pricing affordability, means-tested subsidies like vouchers to help those of modest means, but without meaning to, right? There's not some nefarious thing going on here. Encourages people to live in risky places. If you get underwritten, if your insurance premium gets paid by the government to live on the beach and you otherwise can, you're going to live on the beach. And there was a sort of plan that codified that also from 1968 called, somewhat ironically, the FAIR Plan, which was meant to be an insurer of last result. Basically, states pool all the private insurance and force them to insure people of limited means so that they don't go without insurance. That's perfectly fine, but that program's been hijacked in places like Massachusetts. The political right likes subsidies for wealthy coastal property owners. It fights for them. Whatever they say their values are, that's the reality. And over free market principles. So the FAIR Plan, meant to cover the inner city poor, covers the majority of coastal homeowners in Massachusetts at low, reasonable rates that are ultimately paid by poor people living inland under less risky places. That is the reality, folks. All right, it's an upscale income transfer, which is all by itself not fair, but it's encouraging all this development on the coast. So I would argue that coastal ecologists and real free market conservatives have a shared interest here. They should get together and stop this from happening, right? Both principles come together. So the net result is massively publicly financed incentives to live and build in risky locations. If you live in such a risky location, not surprisingly, you might be in favor of that. But the rest of us are paying the bill. So because of this, we can predict with confidence that U.S. coastal hurricane-related losses are just going to increase over time, whether the climate changes or not, okay? It will be exacerbated by sea level rise and possibly by changes in the hurricanes itself. On that last point, these are, again, from my group at MIT, projections of the sort of destructive power of hurricanes making landfall from 6 latest generation global climate models that have these hurricane models embedded in them. The bar on the left is meant to cover the period 1976 to 2005. The green bar shows the spread among the different models that were downscaled. The right bar is for the last 30 years of this century, about triple, but with a very large range of uncertainty, which is what we have to work on in the climate modeling community. Now, when we translate that into money, this has been done very effectively across a very large number of risks in something called the American Climate Perspectives, Economic Risks in the United States. I strongly recommend that to you. This is just one of many, many chapters in that prospectus that looks at the increase in hurricane damage in the US over what we have now in billions of dollars. So the lower left is for the year 2030. The middle, 2050, 2100 is at the right. The blue is increases expected just from changing sea level, increasing storm risk. The green is from increasing sea level and projected increases in storminess. And again, pretty large error bars on it, but we could be looking at an initial $80 billion years in losses from hurricanes at the end of the century. That is only one of many climate risks we face. So let me try to wrap up here so that there are time for questions. Hurricanes globally take about 10,000 lives and cost $700 billion annually. The response to this actual threat and the perceived threat depends very much on local and national culture. You know, we can sit in our labs and formulate policies, but at the end of the day, I would argue, and I'm not a social scientist, I just see what I see with my eyes, the policies really have to take into account the local culture. What works in New York might not work in New Orleans, and vice versa. And then we start going to other parts of the world. I'll tell you a little side anecdote. We tried to figure out after 18,000 people were killed in Hurricane Mitch how we could have prevented it and how we might prevent that. And we started to think about taking everything we've learned in the United States and shifting it there. Well, we already had done that before Mitch. And so we got the authorities, which in this case meant mostly the police, to go around knocking on doors, telling people that a big flood was coming and they better get to high ground. Makes sense, right? In those parts of the world, when a policeman comes to your door and says, get out, there can be only one reason for it. They're going to rip you off. And so it failed, all right? It just didn't work. And what we realized after the fact is that we should have recruited the Catholic Church to do this. Don't laugh. I mean, because the priests would have gone around and knocked on doors and people would have listened. That's an adaptation. You know, we can't force them into our cultural bracket. That's an adaptation to their culture. That would have saved a lot of lives. That's what will happen next time. Greatly increasing coastal population, coupled with rising sea levels and possibly increases in the frequency of intense storms, do portend ever-increasing hurricane damage and mortality. I know that's a doom and gloom statement, and it doesn't depend upon qualitatively on whether the climate changes. I'm not making a climate prediction. Climate change makes that worse, somewhat worse. But it's true anyway because we keep encouraging people to move to risky areas and we get other people to pay for it, okay? I'm not making this stuff up, folks. I mean, I'm talked to a lot of people whose profession is to understand this problem. These trends really do make it urgent to revisit and reform hurricane-related policies. Adaptation pathways, as I've said repeatedly, depend upon location, long-term versus short-term viewpoints, and things like assumed discount rates. And these hurricanes are just one among many climate hazards we have to think about and mitigate and or adapt to. Thank you very much.
Thank you, Dr. Emanuel. We have some time for questions. We actually have this venue for a little while longer. Maybe give people a chance to leave if they need to go to another session, and then we can provide some questions.
No, I don't actually. Yeah.
So I'll go ahead and start with a question that I just received. Why aren't we zoning high-risk areas against development?
Well, that's a very good question. I like to think that if we were thinking about zoning areas that were currently uninhabited, we would do just that. I'm not sure about it. Financial incentives and pressures from developers can be very, very tempting. And I think, you know, I've heard rumors that this goes on in Boulder as well, the pressure from developers. There is the question in already developed regions is how do you handle the fact that people are already living there, right? And there have been a variety of approaches which have been tried and almost always withdrawn. For example, South Carolina for a while had on its books a rule that if you lived within a certain distance of the coast and your property was damaged more than 80%, it became the property of the government of South Carolina. They would reimburse you for fair market value, but you would not be allowed to rebuild. That wasn't very popular among coastal homeowners, and it went away. They briefly contemplated doing buybacks like that after Sandy. It's just unfortunately an unequal fight politically, because you have a few very, very passionate people, and the rest of us who aren't at risk are, without really realizing it, paying a little bit too much property insurance premium, a little bit too much taxes to underwrite these folks, so we don't complain.
Kerry, I was wondering if you could comment on the usefulness of satellites, given the current climate, in terms of forecasting what these storms are going to be like.
Yeah. That's a really good question. Everybody hear it? How have satellites helped us do this? The answer is enormously. The amazing forecast skills I showed you in those two cases, they're not all hurricane forecasts that good, but demonstrably our ability to forecast the tracks of hurricanes has improved tremendously over the last 30 or 40 years. It just has. And we're just much better at it. And there are many reasons for it, but the ability to observe storms from space is one of the big reasons we've been able to do that.
I have a question here. As the climate changes, how is the jet stream affected, and does this increase hurricane frequency or power?
That's a good question too, and it's not one in which the community of scientists who study climate have a settled answer to. It's actually a complex issue. Most model studies I'm aware of, but basic physical reasoning suggests that the jet stream should shift a little bit poleward, whether they become stronger or weaker. Hurricanes form in regions very far removed from jet streams, on the other hand. So while they're in the tropics, that's not a big concern. But when they move out of the tropics, like Sandy did, Sandy was very strongly influenced by jet streams late in its life, that becomes an issue. So one of the questions I pose to my own colleagues, which we don't have an answer for yet, is how will these so-called extratropical transitioning hurricanes like Sandy be affected by climate change? And I think that's an answerable question, but to tell you the truth, we don't have the answer now.
This is a student question. Do you feel that the naming convention of storms played into the death toll of Katrina and Sandy? I have heard that people are less likely to evaluate during storms with female names.
Ooh. Well, I don't know the answer to that. I will say that I do have a recommendation for changing the naming convention back to what it was in the early days in Australia. Australia started to name storms before we did. And I kind of think they had the right idea. I'd like to hear your reaction to this. They named their storms after unpopular politicians. I think that's a positive reaction.
Another question. Sorry, my eyes are not holding up too well. Why aren't graphs like you presented given to large coastal population areas to explain how often a Category 3 or higher hurricane will affect a risky area? So in other words, why aren't these graphs used to tell citizens, here's how often you ought to expect this?
I think the reason that that information doesn't get to people who need it is that, first of all, I sounds a bit Machiavellian, but I think there are a lot of people interested in making sure they don't get that information. But I would argue that in our particular market system, it's pricing that is supposed to communicate risk, not scientists like me standing up and proselytizing. You know, I have done this, gone to Florida, North Carolina, and saying, do you realize, and so forth. You know, maybe I could influence a handful of people. That isn't the way to do it. Maybe some people just look at me and say, oh, it's just a scientist. And, you know, the way they get the message is through pricing. And we stop that. We are interfering. You know, It doesn't matter whether you're a free market type person or not. But the free market does have a mechanism for sending the signal of risk, and that's pricing. And we're stopping that. We're stopping that through laws and policies. And that's what should change, but the political dynamics don't seem to allow it to change. And I feel that we're sitting on this terrible, tragedy, unfolding tragedy, knowing how it's happening, watching it unfold and feeling helpless to do anything about it. Like sometimes you have nightmares like that. You know what's going wrong, but you're paralyzed. I kind of feel that way.
Are the models showing an increase in hurricanes moving polewards, like Sandy and with climate change?
Well, that's actually a question we do have an answer for. My colleague Jim Cosson and his colleagues, he's at the University of Wisconsin, have done a wonderful study. I actually participated in it, using satellite data to show that the latitude at which tropical cyclones all over the world reach their peak intensities has been, over the last 30 years or so, increasing. That is, storms are peaking in the northern hemisphere further north, and in the southern hemisphere further south. And the models, we went and looked at the models, and that's consistent also with what the models are predicting. So that is another, there are many, many aspects of how climate change affects hurricanes. And I only really touched on that a little bit here, but that's one of them that's important.
Go ahead. Just, yeah, that's fine.
How will NOAA, hold up again, during this administration? Like, when I look at the weather forecast,
Yeah.
will it not say what it's supposed to because they're going to cut
Yeah.
down on the budgets? I just want to know that when it says sunny all week, that it's
Yeah.
true because it is true, not because they want it to be true.
So the question, so everybody hears it, is NOAA going to be prevented from doing accurate forecasts because of politics? Are we going to have alternative weather forecasts? I don't know. I have to say that my feeling is a decided no to that weather forecasts will be fine, and I'll tell you why. A lot of the same people in Congress and so forth, and I do talk to them a fair bit, who want to stop climate research and so forth, for reasons that I can only guess at, are almost rabidly enthusiastic about weather forecasts. And Sandy had a lot to do with that, because Sandy showed us that American models were behind European models in forecast skill and many, many different metrics. And Congress finally got it. We've been trying to tell them that for decades. And they're pouring money into improve. Just last week, Congress passed a bill. Jim probably knows more about it than I do, putting more resources into U.S. weather forecasting. So it's not all bad. I think weather forecasts are probably going to be in pretty good shape.
Go ahead.
Yeah, in 2005, you predicted an increase in major hurricanes, and since then has been the quietest period on record for U.S. major hurricanes.
Right.
So if you could comment on that.
So actually in 2005, I pointed out that there had been a big increase in hurricane activity, and predicted that globally there would be an increase in activity. So, and as you correctly point out, it's been very quiet on the U.S. seaboard. They're not contradictory. The Atlantic Ocean has only about 12% of global tropical cyclones. Only about a third of those, we're down to 4%, influence the coast. And only a small fraction of those are really destructive. So what we were predicting was globally. And the data is of that, is less than 1% of that data we've had to detect U.S. landfall. So U.S. landfall is, because it's rare, is a squirrely statistic. You'd have to wait, I would argue we have to wait 70 or 80 years to see a climate signal in U.S. landfalling hurricanes. And other people here, for example, in Boulder, have come up with numbers like that too.
I want to know what you feel about media or the social scientists, whether they're doing a good job in conveying the dangers of animals.
Well, I happen to think that social scientists are doing an excellent job. They're doing, from my point of view, they're doing a very good job on this. And organizations like the World Bank, I just got finished working for the World Bank to look at current and changing risk on the island of Mauritius in the Indian Ocean. okay? A lot of governments around the world, small nations, island nations in particular, are going to places like the World Bank and asking, how do we evaluate our risk? They come to people like me and my colleagues, and we try to do our best. What's not happening is this is not happening in a coordinated international way. And there are a lot of countries whose risk is increasing who don't ask that question, so it's complicated.
Do insurance companies consult with you on your research?
The answer to that question is yes, they do. Insurance companies do. Now, insurance contracts are 1 year long, and nothing I've been talking about today will have a noticeable signal on the time scale of 1 year. So it's not so much insurance companies that want to know that. They like to know their current risk, of course, as reinsurance companies, the folks that insure insurance companies. And those are typically offshore, international, and have holdings all around the planet and think on a much longer time scale. And they're all over this problem. They're constantly coming to me and my colleagues all over the world wanting to know more about hurricane risk and how it might evolve.
Maybe one more question if there's one out there.
You started your talk about damage from water being more important than wind, and yet hurricanes are categorized by wind. Is there any interest to develop a new scale or measurement that would better predict or give people an idea of how dangerous a storm was?
Well, that's a really excellent question. Did everybody hear that? The gentleman made a very important point. We have this system that's been around for 40 years, I think, called the Saffir-Simpson scale, and I've used it in my talk, Category 1, Category 2, etc. It's based strictly on wind. And yet, I told you that most of the death is from water. And there's endless controversy about this in our field, in the field of sociology of managing disasters. Should we change this? And lots of ideas have been floated. It keeps going around in circles. The problem is there is no such thing as a single number that conveys the risk. And I'm out there. I'm out in left field compared to my colleagues in what I think should be done. And my attitude is there is no substitute for a very carefully worded warning from a human being who knows what he or she is talking about that describes the present risk without numbers. Just because we can't come up with a single number. And people have tried and tried, we just can't. The nature of the risk is completely different. Andrew, which was a terrible event, it was wind that killed people. Sandy and Katrina, it was water that killed people. And we have to try hard. But I think we can't take human beings out of the mix in the communication.
Dr. Emanuel, thank you very much for a very enlightening talk. I'd also like to thank Dr. Hurl and NCAR and UCAR and certainly the Roberts family. Thank you so much for joining us today. Thank you all.